So this is the third slide that we're going to look at today, and we're still working on the same concept. The only difference here is that in the previous cases, we had a defined value that we were approaching, as x approaches a, right? So what we are looking at here is just looking at a being a variable. In other words, we should be able to plug in any value that we are approaching and figure out what the essentially the slope of the tangent line is along the curve. And so this is going to be a more abstract version, whereas before we had an identified value for the slope. In one case it was 8. I think in the previous case it was -1/4. And so in this case we're going to have an equation. Now, if we wanted to identify the slope at a particular point, we could do that. But now we could do that for say multiple points, because we have an equation and we just need to do input the values that we want to be approaching and then figure out any number of slopes. Okay, so I think it'll make sense after I do it, and then really after I complete example 3.12, and we do notice at the bottom it says try graphing the derivative of a quadratic function. I think that'll bring all of that together. So let's go ahead and share our Paint. And let me just double check that we are indeed recording. Okay, so we're gonna use the second definition. So we want the limit of brackets f of a plus h, so it's a square root of a plus h minus and we're gonna use simply x, because a is not defined in this case. So slight modification here. If you go back and look at the formula, you'll find that it's x plus h is what we're now. This is still as h approaches 0, minus x over a square root of x, because that's f of x over h. Okay, now we need to simplify this because we can't directly plug in the 0 at this point. It would be indeterminate. So the way we're going to do this is we're going to take the limit brackets, and I think we've done this before, where we take a part that has a minus sign in it, and we're going to multiply by the conjugate. So the conjugate would be the square root of x plus h plus root x now we have to multiply the numerator and the denominator by that, because essentially we're multiplying by 1, right? So we need to multiply by a term where the numerator and the denominator are identical. And just for space, I'm going to come all the way over here. That leaves me with the limit of, and so I'm basically going to FOIL this out, and x plus h, that's the first. The outer is, there's going to be, well, the outer and the inner are going to cancel, and because they're conjugates, so I don't have to worry about outer and inner. And the last is minus root x times root x, which is x, and this is over h, and times the square root of x plus h plus root x. And I think you start seeing then that those x's cancel out. And then additionally, those h's are going to cancel out. And let me just make sure that I'm leaving h approaches 0. And so I'm left with the limit. I know it looks like the whole numerator cancels out, but given the expectation that you can do some basic algebra, I think maybe with a little review, you'll remember that that's a 1. This is x plus h plus square root of x, brackets as h goes to 0. And now if I plug in the 0 for h, because now it does not become indeterminate, I end up with 1 over 2 square root of x. Okay, and that is a function. And now at any point in this curve, right? So we've got the square root of x, and I'll just very crudely here graph it, and I'll use just a different color just to make it kind of stand out. But it's going to go something like this, and no matter what x value you might be interested in, you should be able to, or you will be able to use that equation to figure out what the slope of the tangent line is. And just by simply plugging in whatever your a is. So, I mean, if you wanted to be real specific and say, oh, well, what if it's 2? Then that would be the tangent line that you'd be interested in, and you could maybe I should have picked something easier to work with, like 4. If I'd have picked 4, well, when I plug in 4 over here, it's the square root of 4 is 2, so it's going to be a quarter. So the slope of that blue line there is 1/4. That's the derivative of the derivative. That would be f prime of 4 using this equation. So let me try the other one. It's going to go in a similar way. And it's going to be the limit. Let's go ahead and use black. The limit of, as h goes to 0, of f of a plus h so put that in brackets minus f of x, which is just x squared minus 2x. This is squared, so this is just a plus h. No, x plus h all over h. And that's the limit of brackets x squared plus 2hx plus h squared minus 2x minus 2h minus x squared plus 2x. Lots of opportunity for error. That's h goes to 0. But I'll kind of know if I'm on the right track if things start to really cancel out and I'm only left with terms that have an h in them. Now those have h's in them, but those will not cancel actually, because one has an x and the other one doesn't. And so let me see, I have the limit of brackets. I'm gonna factor out an h. So it's gonna be 2x plus h minus 2. So it's this term, and this term. But I'm factoring out an h from all of them. And of course, h is going to 0. So that those cancel. And if I plug in the 0, I'm left with 2x minus 2. Interestingly, so this is f prime of x. And let's see if on another, well, I think I know, I think I can make this smaller, perhaps. So I just want to make the point of what this has to do with a graph, right? So so that I can wrap up this example. So that's my y-axis. And then this is my x-axis. And then my equation was a parabola, x squared minus 2x. So I know that's one of the intercepts. I'm doing some analysis of the graph to get a decent picture here. So it's x minus 2. So I believe 2 is the other point. So this is 1, this is 2. And I have a curve. I do have some challenge drawing curves here, but let me give it a shot. Oh, that's not terrible. Okay, so so the other line is the derivative, which is over here, is a line that looks roughly like this. I'm going to draw it in green. Oops. Let me try it with this line here. So I'm going to do it there. And we'll just make a really big point here to illustrate what I'm trying to get at. Okay. So notice that for a while the slope of this curve is negative. Well, that corresponds to this part of the green line. And then from that point on, the slope, actually, so there's a point where the slope is 0. That corresponds to that point. And then finally, I'll use brown, the slope over here is positive increasing. The slope of the tangent line is positive but increasing, just like this is positive and increasing. And so that is the relationship between this, and I know you can't see it anymore, but the original curve.